All right, hey folks, thank you for taking the time to watch this video. My name is Stephen Klontz. I'm the lead developer of the CheckIt software that's used to create randomized exercises. With me today, I have my friend Tien. I'm going to let him introduce himself.
Hi, I'm TNG, and I am soon to be assistant professor at Oxford College of Emory University, and I am a previous CheckIt author.
Previous and current and upgrading soon. And I should mention, of course, also my institution, I'm soon to be associate professor of mathematics, at the University of South Alabama. Yeah, and thank you, Tien, for being on this call with me. I've done these Zoom tutorials, these YouTube tutorials, this will be posted to YouTube later, tutorials before, and I find it really useful to have somebody else, especially someone like yourself who's in the process of porting your 0.1 banks to 0.2 banks, helping other folks start 0.2 banks. I do notice that I need to upgrade or I need to fix this version on this checkit.klontz.org webpage to say 0.2. I'll fix that after this video because CheckIt 0.2 is out. What does that mean for us? So what I want to talk about first really quickly is the end product. What are you producing when you author a bank using the CheckIt software? Well, you can check out the demo, which I have pulled up right here. And the gist is this: you want to create learning outcomes aligned exercises. And so for this demo bank, I have kind of a hodgepodge of various different things. And you can see that the end result is randomized problems with back of the book style answers. And then I'll show you in a moment how you can export those. So first of all, what I usually do with these banks for when I'm teaching a class using a CheckIt bank is I share this website with my students because it gives them 20 practice problems with back of the book style answers that are aligned with each learning outcome of my course. So I find that very useful for students to get their practice in. But then if you click the instructor features, you can see a bunch of things that doesn't hurt students if they do see it, but they don't need to. It's just a lot of extra buttons they won't care about. But as instructors, what would you like to use this site for? And this is something that even if you're not going to author a bank, you can take advantage of these. So if you are authoring a bank, which is the main purpose of this video, this is the service you're giving other instructors that want to use your problems, your learning outcomes, and those randomized problems that are associated with those learning outcomes. And it's the ability to, my favorite, old features that are still around is export each of these practice problems into various formats, LaTeX, HTML, and pretext. And embedding them into your LMS. I like to use the embedded HTML thing, which makes a similar version of this page, but it's got all the extra headers out of the way to make it perfect for embedding in an LMS using an iframe, using that whole code that you see right here. Just paste that into your LMS. But the really neat new feature that I'm really happy about is this ability to tweak the template. So let's say that you're teaching this course, you want to teach about line slopes, but let's say you don't like that the bank author randomly chose the prompt. Sometimes for each of the line equations, identify the slope, or maybe you prefer rate of change, something, whatever you want to call it, right? But when you do that edit, you didn't see that because that was the other version, rate of change. There you go. You can see that live update in the exercise, and even if you click away, that is still around. And so now all the problems are going to say rate of change instead of slope. And you can basically edit, as long as you're not changing the underlying data, the random bits of the problem, you can move where they appear. But as long as you're not changing the actual random bits themselves, you can see what those are down here. You can't edit them though. That is a nice way to tweak it to your taste. And then as long as you don't refresh, because if you do refresh, it will revert back to the originals. Hopefully in future versions, I'll give a way for you to save that locally on your computer. But as long as you don't refresh, that change from slope to rate of change. Oops. Back to the right size. That'll stick around even in the export process. There are two main ways to export these problems for use on assessments. One of those ways is the assessment builder. So let's say we want to ask a couple of line slope problems and a matrix problem. Then I can go over to the assessment builder, change the order of which I want them to appear in my assessment. This is an old feature of CheckIt that's still around from previous versions where you could generate and regenerate. And this is way more than the 20 versions that the students see. They can get more versions if they want, if they wanted to create their own assessment, I guess, but there's like 1,000 versions of the problem. This is not something students are going to just memorize all the answers to. And so this is something that you can then export. You can copy the LaTeX to any LaTeX compiler. I just have like the one-click to overleaf. If you're logged in, it'll just immediately pull up and build your PDF. Notice that it still says rate of change, even though I misspelled change. Download the PDF, and then you can print it. And I have very frequently just come to campus some days and was like, oh, I need to give my students a quiz on XYZ learning outcomes. There we go, instant quiz with random problems on it. I can make multiple versions. I can regenerate, export a different version. It'll have a different version ID at the top, but it'll be the same learning outcomes. So I'm assessing the same learning outcomes, but with different problems and as many different versions as I want. And so those are the main features. This is the why would you want to build a CheckIt bank if you've never built one before, because we're going to walk through today, how do I build this bank, and then how do I share it on the public internet. This won't be, you don't have to buy your own domain like I did. In fact, most of my banks, I don't use my own domain. I use the GitHub, free GitHub hosting that I'm going to teach you how to use today. That's what I use for my differential equations bank. I should really mention quickly that there are DiffyQ banks, there are TBAIL banks. What does that mean? Well, basically for CheckIt, it's just calculus and linear algebra banks are available through this library. And then actually every bank that is made available to the public is available through that bottom link here. More publicly shared banks available via GitHub. And I'm going to teach you today how when you get your stuff on GitHub, you actually automatically share it with others for free. If you don't want to do that, I'll tell you the one thing you need to tweak so it doesn't become a publicly shared bank. But I really hope that you do share it. This is really what I want this to be, a community and a platform that lots of folks are contributing to so that we are not reinventing the wheel for each other. Thank you, Tian. I was just about to ask you, and you said in chat, what else should I not forget to mention? The other really killer feature is the LMS export. It supports right now, previous versions supported D2L and Moodle. I do not have that support in 0.2 yet. So if that's a necessary feature, you'll want to stick with the old version of CheckIt for now, but definitely whine at me about it. Let me know that you wanted to upgrade and you couldn't, because in that way I know that I need to, in 0.2.1, try and get that back up and running for you. But that's definitely, we'll come back if there's a request for it. That's not going to be a problem. I just have to do it. Let's see here. So you can change the name of the bank, and that actually changes it everywhere until you refresh as well. We didn't refresh over here, which means that the edits to rate of change are still around. So when I export it to the LMS, as long as I don't refresh, I'm going to get all those edits that I made without logging in anything, just going to the browser, and then I can export it to Canvas, and it's going to show up either as an essay response or a file upload. This is kind of a slow process. I'll click the button. You just got to be patient with it because it's crunching through 1,000 problems of each type in order to get those, other than the 20 that are on the homework, the ones that all the students might have the answers memorized to. It's the other 980 that are being exported to your LMS. If it says it's unresponsive, just wait and be patient. Because again, like I said, there's just a lot of different problems there. There's one other feature I should show. There it goes. So again, it takes a little while to build it, but you only have to do it once, and then you'll upload this to your Canvas. I don't think I'm going to go through that right now, but if there's questions about how to do this, first of all, if there's questions about anything, we have a wiki now. So it's really sparse at the moment, but I really hope that everyone will help me flesh out this wiki with answers to frequently asked questions. So definitely one of the things I should have on the sidebar here is LMS export, walking through that. Hopefully I'll have that here in the future. All right, any other features, Tian, that I should not forget?
Well, for authors who are used to 0.1, who are now transitioning to 0.2, you'll be very happy to know that there are pictures now.
That's the other, yeah. I knew it. I knew I was going to forget things. So you can see this. Actually, I'm going to show this off in the. Well, I'll show the demo bank, and then I'll show it in an actual bank. All right. So I have in images, and I'm going to do an example of that today as well. So here is an example of an exercise with a random image, and you can see. So there's two parts here. Let me zoom out just for a moment to get it all in the window. But you can see it's randomly deciding whether it's going to ask you to sketch a graph, and then you can see the answer there, or vice versa. You get the graph and you need to find the equation for that graph. And these are generated randomly. You can see here that in the randomized data, these we've defined these different lines, and then there's a place to insert that image in here using this tag right here. Image support, the one caveat about that is that it is possible to get these working in LaTeX, but there's a little bit of manual labor in terms of saving and uploading these pictures to Overleaf, or saving these pictures to the right place for your you just have to look at the LaTeX file that it produces to see where it's looking for that picture, and you can edit it as you want. But that's maybe in a future version. I hope to have a zip download. That seems like something that might be not too hard for me to implement in the future. So if you're using CheckIt banks with images and doing printed quizzes, and that's your priority, and it's being a pain in general with CheckIt, first of all, if you're not already on the alternative grading Slack, definitely join that Slack. We have a channel that we use in that Slack for communicating about the platform. That's a great way to get me feedback as well. And Twitter, we have a CheckIt Problems Twitter account that I don't think I've linked to from this page, but I think it is twitter.com/checkitproblems. There it is. So if you are on the Twitter app, and then you can follow us there and get help, questions, answers. All right. Oh, and then finally, you could, this is our generating images. You can do manual images. So these are just random, ones and twos and threes that I drew in Microsoft Paint, and it's randomly picking which one it appears in each question. So you can, in that situation, you want to, maybe you have 10 different graphs of data, like scatter plots or something from actual data, that you've collected, and you can randomly choose which one you're going to use for that type of problem, and then display that for the student. And then finally, I just said I mentioned it. I just really like this question. This used to be a really hacky question in the old version of CheckIt, but now I have actual slope fields. One of the other advantages of CheckIt, if you're used to things like web work and other randomized problem generators, is that CheckIt uses SageMath, which is an actual mathematical programming environment. So you're not trying to hack things together in Perl scripts to make them work. It's going to be a much more, I did not ever program how to generate a slope field. That's just a feature of SageMath that we're now able to take advantage of in 0.2 CheckIt. All right, I don't want this video to be too long. So anything else before I ramble too much, Tian? All right, let's talk about actual offerings. This is what we're going to get out. Let's talk about how to make this. How does this get onto the internet? So for this, I use CoCalc. If you're not familiar with CoCalc, CoCalc is there's a free level of service, and for not too much money, I think it was I made a temporary paid license to get a few extra resources for folks who are, again, if you're on the Slack, you have until the end of this week to try this out with the paid version of CoCalc for free. I think I've spent like $3 for 2 weeks to get that available. So it's really a reasonable way to just have everything just work for you. But if not, then I'm actually going to show, if you're using CoCalc, what I'm going to do for this video is I'm going to use the Jupyter Lab notebook server, and I'm going to use the Visual Studio Code server. And if you're not using CoCalc, you can follow the exact same steps. Just install your own Jupyter Lab server and install your own Visual Studio Code program on your computer, and it'll be on your computer instead of through your web browser. But the steps are going to be almost the same whether you're using CoCalc or not. The big difference is CoCalc has a lot of stuff pre-installed for you. So if you're doing on your own computer, you've got to have SageMath installed. Just Google SageMath. That's SageCell. That's another useful, but not quite the same thing. You Google sagemath.org. That's it. Sagemath.org. Install whatever version of SageMath you want. you're going to need to do that. And then you'll need to have a version of Python installed that you can access from the command line. So python.org, I'm pretty certain, is where you can get the, it needs to be a version 3.8 or later of Python. So again, I love CoCalc because I don't have to go through all these steps to get that installed. You may already have it installed though. You may be ready to roll. So let's assume you've got SageMath installed. Let's assume you've got Python installed, okay? Then what's the next step? Well, if you've got both of those installed, then, and you've got Visual Studio and Jupyter Lab installed. So those are the prerequisites. And if you're on CoCalc, you get all that for free. Even on the free tier of CoCalc, if you just log it, this is a new thing. If you just go Python M CheckIt, sorry, let's do pip show CheckIt. So if you do that, no, package not found. Sorry, CheckIt dashboard. Run a little slow for me right now. I wonder why. There it goes though. Yeah, I've already got, because I'm on CoCalc, I've already got the 0.2 version of CheckIt dashboard installed. I just asked CoCalc to make that available automatically for all new CoCalc users. So you probably already have that available to you if you're in CoCalc. No worries. If you don't have it already, python-m pip install --upgrade, just to be safe, CheckIt dashboard. And this instruction, of course, is also on the GitHub page. You might want to upgrade pip. I forgot to do that. So you could upgrade pip first, but here's the command right here on the CheckIt GitHub page. So now that we've gone through, and it's just saying, it doesn't hurt for you to do it without checking that it's even there, because it'll just say requirements already satisfied. Finally, the last thing we need to do is Python M CheckIt, Python-M CheckIt. And if I do that, it creates a new CheckIt bank in the folder, new CheckIt bank. So I can open that right here in my Visual Studio. And now I'm in that new folder, new CheckIt bank, and it automatically installs all the files you need to get started. Just that one line, Python-M CheckIt. So you're going to want to have, once you've run that, you're in your new CheckIt bank. You could also give it a different name. You could change the folder name, no problem. And then finally, yeah, you want to be in that bank. You want to have your outcomes, get, ignore, bank, dashboard, readme, and requirements. So a few things we'll do here is, it would probably be nice to change the name, my new bank's name, and the readme, just so that when people find this on GitHub later, they'll be able to know what exactly this is. Requirements, you don't have to edit that at all. That just says that you made this CheckIt dashboard using version 0.2. The dashboard itself, if you look at that in, you know what? I've never even tried this. We're going to try this live on the video. If I run this, yeah, it's going to yell at me. Okay, I didn't think it was going to work. So your Visual Studio Code, if you do a lot of Jupyter notebook stuff in Visual Studio already, it may just work, but we're not going to do that. That's why we have Jupyter Lab. So we're going to leave that alone for now. The other thing that we have here is, this bank.xml, we can see right here, we have a bank with a single outcome. It's just called sample outcome. It lives in the outcomes ex1 folder. This is something new. So if you're an existing CheckIt author, this is very familiar to you. Obviously change your 0.1 to an 0.2 on the bank XML. A few different things that used to be there, like the alignment. You could used to be able to say what textbook this learning outcome matches. That's no longer a feature. You could put it there, but it won't do anything. The biggest change in the upgrading process is that it used to be you just wrote your slug, and then you would have a file called ex1.sage and ex1.xml. That's no longer the case. You just have an ex1. Well, actually, you could make this live anywhere that you want on your computer. My recommendation is follow the pattern that the default outcome does. Make an outcomes directory, and then make a directory that matches your slug. And so what you'll do is once you make a directory that matches your slug right here, then that folder will contain two files. What used to be ex1.sage and ex1.xml. Now the folder is called ex1. So you have a generator.sage and a template.xml. And you can have other files in there as you want. Those are the other things that you may have other related files for your learning outcome that might be important. And you can just stick those into this same folder, and it won't hurt anything. So it's going to be making people have bigger banks. It'll be much easier to organize where all the different files are living. All right. I think before we go any further, let's just go ahead and see what the authoring interface looks like. And that's where, like I said, you're going to try and do it through VS Code. You need to select a kernel or install a kernel. I don't want to do any of that. I should actually look into that. Maybe I'll do that in a future video if I find that way to get it all through VS Code. That wouldn't be bad. But for now, we're going to use Jupyter Lab. And so here, I don't see the new bank, but if I hit refresh, there it goes. So I can open this in my Jupyter Lab interface, open up the same folder. So you can see the same files here as you see here, but all we need for Jupyter Lab is the dashboard. And this says to run the cell below. And I don't, there's the run button right there. All right, so now that we've run the notebook, now I can, there's only two things to do in the current version of CheckIt. You can either author or edit an outcome, or you can manage the overall bank. So let's just start by looking at what does it look like when we author or edit outcomes. So generally speaking, what I'll like to do is I'll have, when I'm editing an outcome, I'll have the Sage file and the XML file. And here in VS Code, I can have them side by side just by clicking and dragging. So this Sage file right here, because I did not prepare this video, it doesn't know that this is using a Python syntax. So I need to remember how to tell VS Code how this is Python syntax. You might need to do this yourself if you don't do a lot of Sage code editing. Let me see here. That's not what I want. Give me just a moment. Feel free to fast forward this video if you're watching this. If you don't care about the syntax highlighting, I need to remember, where is the thing? Oh wait, I can pause this recording. I'm gonna pause this recording real quick for y'all watching it. All right, we're back to recording. So the trick to get the highlighting so it's easier to read the code is to go to your settings, which may be a little bit different depending on which version of VS Code you're using, but opening up your settings. And then I think the easiest thing to do is just use that search thing for file associations. And then you can add star.sage to be Python. Do that, okay. Suddenly I've got my beautiful syntax highlighting. All right, we're back in business now. So that's one of those obnoxious one-time things in the setup of your VS Code. But now that we're here, we can see what an outcome looks like in CheckIt. There's two pieces to randomizing these problems. You've seen the template before. Now this is another change from early versions of CheckIt because we're using the SPA-Text 2.0.2, which 0.1, previous versions of CheckIt, SPA-Text was just pretext, which is another very commonly, very, very great open source language for describing open source textbooks and similar documents. But for CheckIt, I realized that SPA-Text needed to go a little bit different direction in order to get that live editing of the templates that you saw a moment ago. And to emphasize that you can't just use any pretext that you want, I decided that it would make most sense to make a SPA-Text specific language. So this is why we have null mode exercise. What used to be exercise is now null mode equals exercise. There are other types of nulls you can make in SPA-Text, but the only one we care about for CheckIt is the exercise null. A null can have content, and that's basically what's the question. Outro, as in the opposite of intro, outro is basically the answer when we're in exercise mode. All right, and so that's gonna be your basic questions. We'll talk a little bit about multi-part problems where this can get a little bit more involved, but that's the basics right there. If you have a question and an answer, you have content and an outro. Inside of those, you should have P's for paragraphs. You use M for mathematics notation. And you can see here that I'm using these curly braces. This is what's called mustache. And what that does is that's how we insert the result of the sum over here in the generator gets inserted into the sum here on the right. So every time we run this, I'll go back over here to the dashboard. If I do a fresh preview, it's going and what it's doing is it's running this code 10 times, and then it's taking this template and injecting the results of this code into the template 10 different times. So you can see here that the sum, once the code is done, creates this LaTeX markup that gets inserted into between the mustaches. And that's why you can see instead of the curly brackets sum, you have the actual LaTeX showing up here in the spa text. Likewise, the result we can see here shows up in each different version. And I can scroll down and see different versions. Here's another version right here. You can see it has different data. Here's what its spa text looks like, and that's how it turns into HTML and LaTeX and so on and so forth. And so this is the workflow that I recommend folks is when you're authoring outcomes, have your dashboard pulled up so you can do fresh previews after you edit a bit. So this is, I can now not just edit the template like I did earlier at the beginning of the video, like anyone's gonna be able to do with your problems to tweak it to be just like how they want it. But when we're authoring problems from scratch, we need to also describe how do we randomize these problems. And that's where you're gonna write Sage math code. Another change from 0.1, it used to be you would write something like def generator. That one line is now 2 lines. Don't worry about what exactly is happening there. It's just some boilerplate that makes some magic happen that you don't need to worry about. You'll need to be double indented. The data function is indented, and then so if you're upgrading, the short version is replace that def generator that you had with these 2 new lines. Just make a sample outcome bank and you can just copy that. The other thing I recommend for folks to do while you're authoring is look at the GitHub for CheckIt, look in the demo bank, and all these different outcomes, you can click through and see the source. So if I wanted to make a line slopes problem, I could just look at the generator for that line slopes problem that we saw earlier in the video. So now that we're here, what's actually happening? Well, this is kind of the really basics of what a CheckIt problem does, is you'll define certain variables using Sage Math. Other piece of advice for authors is just Google Sage Math and like Sage Math scatter plot. If you want to make a scatter plot, then just search for Sage Math scatter plot, and it's going to give you all the code that you need. Don't copy the Sage bits here, just the code here on the right. That's going to tell you what you need, and you can do some copy pasting into, if you don't know quite all the ins and outs of Sage Math. Speaking of which, if you know Python, you basically know Sage Math. It's based on Python. You can just copy that over. But the basic things you're going to be doing are like defining variables, picking random numbers within a certain range, and that's all this problem does. Is it creates what does it create? It creates 2 different monomials and adds or subtracts them together, and then that's the result that the student needs to do. And so what do I have going here? I've got a power p that I want to be between 2 but less than 6, so 2, 3, 4, 5, and then I have a and b are both random numbers between -9 and +9. I should probably have ruled out 0. Come to think of it, if I was being more clever, I would have ruled that out. Well, in fact, let's do that. Let's say we realize, oh, this is not a great problem because sometimes one of the things we're simplifying turns out to be 0. See if I can find one. 10% chance every time, right? At least. There we go. Simplify 3x cubed. 3x cubed. Not a very great sample outcome, I guess, but perfect for illustrating. So a way I would probably change this is, well, the cheating way, I guess, would be let's just make it all positive, right? Let's just make sure we're always picking between 1 and 10. I could do that, so I made that change. Now if I do a new fresh preview, I don't have to rerun the whole notebook. I just have to click the fresh preview. And now if I do that, I'm going to get other random problems, and it's always positive now because I switched the range to always be positive. All right, let's say I want to have some negatives in there though. I could multiply that random number by a choice of either -1 or +1. And I'll do that for both of these. And then if I rerun, thing to note, VS Code automatically saves the edits to the stage file. So if you're using another text editor, you may have to actually hit Control-S or save it. But as long as that update has been saved, I can scroll back up, click into Fresh Preview. All right, and now we have some negatives. We have some positives and negatives. So the one thing I did not do was guarantee that they can't be negatives of each other. So the answer could be 0. I don't know if we're going to get that in 10 random problems, but that's something else that you might want to choose to optimize. If you feel like you don't want the answer to just be 0, you'd have to put a little bit more thought into the code generating this stuff. But at least now I'm not spitting out 0 as one of the things I'm trying to add, because that's not very interesting. Okay, so that's the basics of authoring. And so really, just like when you learn anything new, like learning the LaTeX, you're learning pretext, or now we have spa text, the best way to learn it is by looking at examples. Look at generator functions, not just from the demo bank, but also any of these other banks. If you're making your own differential equations bank, what I'd encourage you to do is go to my differential equations bank, go to my GitHub for that bank, and just take a peek at my outcomes, take a peek at my generators and my templates. I have licensed my bank. This is not done automatically, but I chose to use the MIT office, so it's licensed, so it is open source license, and I want you to take my work and riff on it. Please do. So copy paste what works, tweak it, and that's the best way to learn. Anything else that you think, Tian, that I should mention about the updating an outcome or editing an outcome or authoring a new outcome?
Do you want to talk images now, or?
So let's do this. Yeah,
process.
let's do two things. So first of all, how do I create a new outcome, not just edit the one that exists when I create a new bank, right? Well, that's as easy as taking this folder and copying it and pasting it. So now I not just have the EX1 folder, but I have an EX1. And you can do this if you're on your actual computer. You could actually just copy the folders like you normally do on your Finder or your Windows Explorer or whatever. I'm going to rename this folder to EX2. So that's step 1. And right now, it's identical, of course, to what I just had because I just copied it, right? But the other thing I'm going to do here is talk about the bank, because if I go back to my dashboard, now in this case, because I'm adding outcomes, I need to rerun the whole dashboard to pick those up, but it didn't pick them up. And that's because I not just have to make the new folder, it doesn't detect that automatically. I've got to tell the bank through bank XML that I've got a new outcome. So here's sample image generation. I'll call it EX2. It's in the outcome/EX2 folder. And it should really be like you normally, describe a learning outcome. At the end of this course, the student will be able to predicate, right? But for now, I'm just going to call that images because I'm going to show you guys how to make some images. All right. So now that I've told CheckIt in the bank manifest, this bank XML, I can go back to my dashboard and rerun it. And then it's picked up that new image. Of course, if I do fresh preview, then it's going to take a beat. It's going to look just like it did before. Let's make some images. All right. So what I'm going to do is, I don't want to spend a whole lot of time here, but the basic idea is, first of all, if you're going to make images, the sample outcome doesn't have that boilerplate in it. So what I'm going to recommend you do is go to the demo bank, go into outcomes, go into images. The first one's where I did random images. And I'll go to its generator. And what you're going to see is that there's a new graphics function at the bottom here, provide graphics. There's a little bit of information here on what you can do. I'm going to paste that in to my EX2 generator. And so it's a separate function from the data function where you define what's happening randomly with your problem. And then here, the example is actually kind of more complicated. Maybe I should have made it a little less complicated, but let's just say you want one picture, okay? So I'm just gonna do one picture, and I'm just gonna call that picture graph, okay? So the graph graph.ping is what's gonna be in my template. And I need to tell Sage, let me get rid of this extra stuff over here so we can just see this code for a moment. So what I need to tell Sage is I need to create what's called a graphics object. And so again, that's just if you want to graph y equals x squared in Sage Math, 2D plotting, you know, this is what I do all the time, even though I write a lot of Sage Math, is I have to look these up all the time if I haven't thought about it. It's just plot. I can just use plot. It's probably gonna have some examples down here of where I can, different ways of using plot. Here we are, plot. Let's just plot, let's just do this. We're gonna plot the sign from 0 to 10, all right? So back over here, I'm gonna plot this plot sign from 0 to 10. Now, if I just do this, and I go back to my dashboard and do a fresh preview, first things first, images are slow. You're going to have to wait a little bit to generate images because it has to go through and generate all the random data, then it has to create all the random files. Okay, you know, I did that. I forgot to put it in the template. It generated the images and it doesn't show up anywhere because I've got to also update my template. So let's go back over here to the example, the template XML. And we can see this kind of image line. I'm going to paste that into my template. Just put it in the question. You can put it in the question or you can put it in the answer. All right, what needs to change here? Okay, first things first, the image one needs to be changed to EX2. All right, keep the assets EX2 generated, keep the seed business here. File name, that is, you have some choices, all right? Because in my generator, I'm always calling the graphics graph. I can just call this graph.ping. That's all I've got to do. You can randomize what the file names are, or if you have multiple files and you have like a loop, you may need to have a variable that tells you which file to use at which part of the loop. But basic usage, you probably just want to have something like this I've got right here. I'm probably going to update that demo bank to only have one image to make that a little bit easier in the future for you to copy paste what's going on there. This is going to be the graph of sign. Description is good practice for accessibility reasons. This appears as alt text on the image for folks that can't actually see the picture. So definitely give a useful, you can even provide some random information to put into that description if you want to help those learners. But now if I've updated both the template, the generator to generate some graphics, and the template to display that graphics, oh, one more problem. The image has to be in a paragraph because nothing is going to show up unless it's in a paragraph. Paragraphs describe the different visible pieces of content within a content or an outro or some other thing. So now that I have done that, hit fresh preview. Oh my goodness, and the graph of sign is not working here. So let's see here. I'll pause the video to bug fix this real quick. All right, so mea culpa. Images are not working in the preview in Jupyter Lab. They are working in CoCalc, so I've got some work to do to figure out a way to get that working in Jupyter Lab hopefully soon. But for now, just know if you're generating images that you won't be able to use, you may not be able to use Jupyter Lab, but it does work in CoCalc currently. Now, one thing I want to notice is that, of course, this sign graph is not randomized, right? It's the same image generated for every single version of the problem. And that makes sense because, I didn't use any of the random data that I created up here. None of it was used down here. So let's modify this problem to actually use some randomized data. So I think what I want is, we'll have the question just be graph sign with a particular amplitude and frequency. So how would I go about doing that? Well, I would probably just call amp. The amplitude will be a random number between -5 and +5, so less than 6. And the period, not actually the period, but the coefficient, let's just call it coefficient because it could go inside. Another rand range, let's make this positive though, 2 to 10. And then the sign is going to be sine of, there's going to be amplitude times sine of coefficient times x. All right. So now I've got this random outside coefficient, inside coefficient for my sine function. I should insert that. The question is going to say graph sine. Y equals, I can put that over here in the template if I like. Y equals sine. And then the answer, the outro, is going to be where it actually shows up. So with those changes here, show them side by side. Oh, I still have this issue that if I run it, I haven't updated the graph to actually use these numbers up here at the top. So fortunately, in this case, it's going to be a very simple thing for me to do. I just want to plot, instead of sine, I want to plot this sine right here. So the way I could do that would be something like, well, I can't just write sine. I've got to actually use the data variable that's being fed to the graphics. So the output here gets fed as data by this provide data thing into graphics. Long story short, if you made it available up here, if you returned it, I want to grab this and plot it. I've got to go say data, and I want that sine variable. So the sine here, I put that into the data with the hard brackets. This data is what's called a dictionary. So these are the keys of the dictionary. So you use the key of that dictionary, put it into the data, and that spits out whatever randomly happened up here. So I think that should work now. Again, I'm going to use the CoCalc Jupyter Notebook because that's the only one that works with images for the moment, and I apologize. But when I get that generated, here we go, -5 sine of 4x. So you can see that the period has been divided by 4, and the amplitude is -5, so it goes down before it goes up. And if we scroll down, -3 only goes down to -3. Let's see a positive one. +4 goes up. So there you go. You could do other clever things. You could have a coin flip of sine or cosine, and of course, just feed it through in the same way. But I want to move on. So does that kind of cover the basis with how to generate a random image and get the data for it? Okay. So great. Now, I think at this point, we've got a bank. It's got 2 learning outcomes. It's got random problems to assess each of those learning outcomes. I want to make sure before we wrap up today that I show you how to share this with the internet at large. How do you, the first step for that is going back to, we can go back to the Jupyter Lab now because the only thing that doesn't seem to be working at the moment is images. But I'm going to go to manage my bank now. Now, if I do bank from cache, it's going to be bad and broken because maybe before I should have done that, what I recommend doing is clicking generate seeds if you don't have a graphics. And that takes a moment, but not too long. And it's going to generate 1,000 different versions. And now if I click new random seed, it doesn't have to do that processing step that it used to do. It would take a while, right? It has them all cached already. Now this fellow right here has graphics. So I could click this right now, but then I would have to pause the video for 5 minutes while it built. This is a long process. So I'm going to cheat for a little bit here. I'm just going to click generate seeds, which means that the images are going to be broken. The way to fix that is I should have clicked generate seeds plus graphics and then got a cup of coffee and come back in about 5 or 10 minutes. So now that I've generated problems for both of these, I'm going to go to manage bank. I'm going to build a bank from cache. And it's instant, pretty much, right? If you've already pre-generated it, let's say if you want to be super safe, it won't do the images, it won't do the graphics, but you can click regenerate bank and it'll go through. Now, it might take a while if you've got like 20 learning outcomes, but it's going to go through each of those learning outcomes and do one fresh generation for each of them. And so that's another way to quickly make sure you've got everything in the right place with the latest edits and updates. It won't do graphics because that just takes so darn long. I don't want anyone accidentally building graphics for their entire bank. You need to do that infrequently. It just takes a while. Okay, I've done it. What does that mean? Well, you can now, on your computer or some on CoCalc, through CoCalc, go to Docs. That new Docs folder, you can see it right here as well. But that new Docs folder has an index on HTML. You click that, there's your new CheckIt bank. All right, there's the one thing that we've been editing. And then it's got my sample outcome where I fixed it so it never spits out a 0. And it's got my sample image generation. The images, as I promised, are broken because I didn't click the with graphics, but it should work if you do have the graphics. All right, and I could even do a lot of the things I want to do, like LMS Export, or sorry, Assessment Builder. I don't do LMS Export. I'll talk about that in a moment. But Assessment Builder, you could do just from here. If you want to quickly make a PDF with your outcomes, you can generate that right here. You can copy that LaTeX or export it to Overleaf, and there we have a PDF with the things we just authored. So this is a nice stopgap thing. You know, you can open it up in either your CoCalc like I did, or you can just open this in your web browser, just off of your computer if you're doing this installed locally. However, what we really want is to get this on the internet so we can share it with other people, share it with our students, share it with other instructors. So how are we going to make that happen? And this is where we're going to have to do a little bit of magic with Git, Git, Git. And particularly, you've probably heard of GitHub, which is a place where people share their software projects. What I will suggest, there's a few steps you need to do. So if you haven't done this before, you need to find a tutorial on how do I push to GitHub, basically. So that's going to be the prerequisite, I think, for this video. So for the sake of time, is set up your GitHub account, set up SSH to connect with GitHub. So if you just Google GitHub SSH, connected to GitHub with SSH, I can't do a video about that because it would be so different if you're on Windows, if you're on CoCalc, if you're on Linux. So that's on you to figure out here. But once you get that step taken care of and you've got Git working with your computer, then you can go to github.com/new and create your new repository, not with a template. You can give it whatever name you want. I'll just take the one they suggested, Sturdy Memory. All right. And then I will keep it public. I will not initialize it with anything. I'm just going to create that repository. And I'm going to use the example, push an existing repository from the command line. All right. Back over here in VS Code, I have this CheckIt bank thing here. I have a few steps I have to do. All right. Git init initializes the Git repository. You see a bunch of files turn green right here. I'm going to do, so one thing I like about VS Code is it shows you all the files in green. This dot file here, I can delete that. That's not important. So I'll get rid of that. So it won't be part of that repository. So now I'm going to git add-a to get all these green files, especially including the docs file. That's important. And then git commit my awesome bank. And then I need to tell it who I am. So again, all this is a bunch of one-time setup stuff. All right, Tian had to drop out of the Zoom call, so hopefully I don't forget anything else. So thank him for pointing out a few things along the way. All right, so I've got this initial Git set up here. And now that I've got that set up, we need to I need to redo that commit. And again, this is stuff that eventually will go into the wiki somewhere. So if you want to help me with that, I'd greatly appreciate it. Otherwise, I'll get around to it as soon as I can. But now that I've got, if I do a get status or get log, I can see my awesome bank has been committed. Now it has to be what's called pushed to this new sturdy memory, whatever that random name was, repository on GitHub. I'm going to use the SSH here. Let's set it up with SSH. I'm going to copy these lines and I'm just going to paste them. I do want to connect. And if you use an SSH password like I do, and you should, then you'll need to paste that in. So that I will actually push. And now, a couple of things have happened. If I refresh the GitHub page, I will see my new bank's name. I see this new bank. And if I go back over here to check it, as soon as you push that to GitHub, it now shows up. It'll be gone because I'm going to delete it after this video, but it now shows up. You have now shared your bank with the community. And so we'll be able to find, so give it your repo name, something useful name, not sturdy memory like I just did. Call it my great calculus bank or my discrete mathematics repository. I don't know. We call it something that we can recognize what subject area you wrote your problems for. And so folks can go click over here and they can, eventually after we do a few things, they'll be able to see the bank. So let's do those few things. Now we've pushed it here, we've got to go to settings and pages. And we need to use enable GitHub pages by selecting the main branch and the docs subdirectory. And now that I've done that, it says your site is ready to be published. And this github.io link is a public link that anybody on the internet can use. So you can send it to your students, but it's only ready to be published. If you want to see that process, oops, go back to your code. Let's see if I can find that. This little orange button right here. This will show you the process as it goes through here. You can click details. If you're impatient, you can kind of see the actual process of the build as it gets done. Looks like that's been completed. So then the deploy, looks like that's been completed. All right, green check mark, we must be good to go. If I go back to settings and I go back to pages, and now we have the green thing, it's published. All right, and now I've got my new bank. And again, the images are broken because I didn't actually generate the images, but I got my new bank with my new outcomes on the public internet with all the great features. I want to say reduce instead of simplify. Now, anyone who prefers to say reduce rather than simplify can make that change, and that'll be exported through the assessment builder or to their LMS for Canvas. What else needs to be said here? One other thing I would suggest doing is take this link, copy it, go to your about on your repository on the code tab, and just paste that in here. In fact, it even shows you a great, I don't know why it doesn't just let you automatically put that in, but copy paste your website there. That way you have a link that people can click so that when they find your bank through the checkit.clance.org website, that GitHub link that's on there, when they find your bank, your repository, they can actually click on this link here to actually get to the good stuff. All right, if they're an instructor, and that's the same for you if you're an instructor, right? That's how you can get to the actual bank. You can also just edit the URL. You can see here, you just basically just move the username before github.com becomes .io. If you do all that, you can edit you can always find the pages if they've enabled it, if they've done those steps. All right, what else needs to be said here? Got so I wish I had TN to hold me honest here, but I think I've gone through all the steps. The one step I didn't show you, what if you don't want to share this? You want to put this on the internet, but you don't want to share this with the greater community? I'll be a little sad, but all you have to do is just get rid of this requirements.txt file. If you just erase that file, right here, delete it. If that file goes away, you can put your stuff on GitHub all you want and no one's ever going to find it. If that's what you want, then that's how you do it. But I hope you don't, because I'm looking forward to see folks share their banks through the GitHub repositories, and that way I know that you exist. I can help you, support you in creating this great bank that hopefully will help you generate assessments and reassessments for your students in a much more quick and elegant manner. And most importantly, I hope to see this community come together and help each other create banks so that we're not all having to write all this code all by ourselves, but we can divide and conquer, write a bunch of great problems for a bunch of great learning outcomes, and then share those with each other so that we can help each other assess our students and support our students. And more importantly, support our students in learning these learning outcomes by giving them great high quality practice problems with as many versions as they could ever want. So thank you for the time watching this video. I'm sure there's a lot of things that I could have said that I didn't say. Please help me make that, build up that wiki. If you figure out how to do things that aren't in the wiki already, please let me know through the Slack. Join the alternative grading Slack. I'll put a link to that in the description of this video. Join us in the CheckIt app channel, and that's a great place to communicate, or just join the conversation on Twitter as well. So thank you for your time. Have a great day.